tutaanza kuangalia topic yetu ya wave motion. Baada ya hapo ili tutaangalia topic yetu ya wave motion ambayo itakusaidia katika mtihani wako wa mwisho. Ni topic muhimu sana, inachukua takriban maksi 20 mpaka 30 katika mtihani wako wa mwisho. Kwa hiyo baada ya kuona tunaanza na wave motion, kitu cha kwanza inabidi tujue what is wave motion. Mara nyingi wave kama wave ni disturbance ya motion ambayo inasababisha transfer ya energy kutoka katika sehemu moja kwenda nyingine. Maana kwamba the disturbance of motion which causes transfer of energy from one point to another without causing permanent displacement of the medium itself. Kwa mfano, kwa leo hii ukitoka zako hapo ukaenda katika dimbwi la maji ukarusha jiwe, utaona maji yanaenda in this way kama cycle fulani. Ile ni experiment mojawapo ya kugundua au kuona nini maana ya wave, zina move outright. Lakini hii situation haitoenda kwa muda mrefu, bi maana ya kwamba itafika stage ita stop, na ndio maana tunasema wave is a disturbance of motion which causes transfer of energy from one point to another without causing permanent displacement. Baada ya hapo kuna aina mbili za wave. Ya kwanza ni mechanical wave na ya pili ni electromagnetic wave. Tunapozungumzia mechanical wave, maana yake ni aina ya wave ambayo inahitaji medium ili mradi iweze kutokea. By means this is the type of wave which require medium material for its propagation. Bi maana ya kwamba pasipo kuwepo na medium material, electromechanical wave haiwezi ikatokea. Mfano, hauwezi kwenda eneo ambalo ni vacuum, bi maana kwamba halina hewa kabisa na ukaisikia, yani mkaongea mkapata kusikiana. Bi maana kwamba sound wave ni mechanical wave, ili mradi iweze kutokea lazima pawepo na medium material, ambapo medium kwa sound wave ni air. Kwa mahali popote palipokuwepo na hewa unaweza ukaongea na mwenzako akakusikia. Aina nyingine za mechanical wave ni wave in spiral spring, wave in stream and the water wave. Kwa hiyo katika water wave, water is act as medium. Katika wave in string, string is act as medium. Katika wave in spiral spring is act as medium. Baada ya hapo mechanical wave na yenyewe imegawanyika katika sehemu kuu mbili ambazo ni longitudinal wave and transverse wave. Tunapozungumzia longitudinal wave is the types of mechanical wave in which the direction of vibrating particle and that of traveling wave are parallel to each other. Kwa mfano, ukichukua spiral spring ukawa unaifanyaje, ukawa una stretch out, yani unaivuta in these directions, it means itakuwa ina move in parallel way. This in parallel way. That's why you call it as longitudinal wave. Na examples of longitudinal wave, kuna wave in spiral spring and sound wave. Katika sound wave, hata mtu anavyoongea zile air molecules zina vibrate in parallel way na kutransfer ile sound yako from one point to another. Maana kwamba wewe ukiwa huku ukiongea, huyu wa huko anafanya nini? Anakusikia. Kwa sababu gani anakusikia? Hii air molecule ina vibrate in a parallel way with each other. The maana tunasema longitudinal wave is a type of mechanical wave in which the direction of vibrating particle and that of traveling wave are parallel. Well, longitudinal wave produce two regions which are nodes and antinodes, as we see here. When we take our spiral spring, then we stretch it out, it will that formation of two regions which are nodes and antinodes. Nodes we call it as spaced out region, and the antinode we call it compressed region. Longitudinal wave can be shown in general wave diagram, as we see here. This one is general wave diagram. The vertical line here is displacement and the horizontal line here is time. When we plug our string here, it undergo in this way. So this region we call it as node. It means the wave is at equilibrium position, but this region we call it as trough or antinode. The wave undergo displacement. Baada ya kuangalia aina hiyo ya longitudinal wave, we shift to another type of mechanical wave, which is transverse wave. And the transverse wave here, this is the type of mechanical wave in which the direction of vibrating particle and that of traveling wave are perpendicular to each other. A good example of travel wave are water wave and the wave in string. For instance, when we tie our string here, then we plug it at the middle, it undergo this way, in this way. So these are vibrating particle, and this one is the direction of wave. The vibrating particle go in vertical way, while the direction of the wave is in horizontal way. It make here light angled or 90 degree. That's why we say that transverse wave is a type of mechanical wave in which the direction of vibrating particle and that of traveling wave are perpendicular to each other. After there, we're supposed to look another type of wave motion, which is electromagnetic wave. Electromagnetic wave, this is the type of mechanical wave which do not require medium material for its propagation. This means that for electromagnetic wave to occur, there is no any medium material is required for it to propagate. This means that the electromagnetic wave can exist or can occur even in a region with no air. A good examples of electromagnetic wave are X-rays, gamma rays, ultraviolet radiation, radio wave, broadcasting wave, infrared wave. Those are good example of electromagnetic wave. Baada ya hapo, mwanafunzi wangu, inabidi tuangalie kitu kinachoitwa electromagnetic spectrum. Naomba utulie vyema na unisikilize kwa umakini ili uweze kufanya vizuri katika mtihani wako wa mwisho. Tunaendelea na electromagnetic spectrum kwa sababu tumetoka kuangalia kitu kinachoitwa electromagnetic wave, na tulisema is the one which do not require medium material for its propagation. So, what's the meaning of electromagnetic spectrum? This is the arrangement of electromagnetic wave in the order of increasing frequency but decreasing wavelength and vice versa. Tuna arrange zile electromagnetic spectrum zangu bimana kwamba gamma, x-ray, infrared, ultraviolet or radio wave in the order of either increasing frequency but decreasing wavelength or vice versa. So consider the electromagnetic spectrum in the order of increasing wavelength but decreasing wavelength. We start with x-ray, gamma ray, ultraviolet, visible light, infrared radiation, microwave and radio wave. As we see here, as you're going down, the frequency decreases but wavelength increases. So this means that the first one here, X-ray, gamma ray, has highest frequency, but the lowest one, radio wave, has the lowest frequency, and the vice versa is true. So mwanafunzi wangu, kwenye mtihani wako unaweza ukaambiwa arrange electromagnetic spectrum in the order of increasing frequency but decreasing wavelength. So you're supposed to start with this one. Unaanza na hii kuja hii huko. But kama ukiulizwa uarrange in the order of decreasing frequency but increasing wavelength, ndio utaarrange kama hapa inavyoonyesha. Baada ya hapo, tunaangalia terminologies used to describe in a wave motion. Yanatokaga maswali yetu either katika matching item au katika multiple choice, au unaweza ukaulizwa what is amplitude, what is wavelength, frequency. Hizi terminology zote zinatumika kuielezea wave yetu ambayo tunaiangalia. Nini maana ya amplitude? Tunapozungumzia amplitude is the maximum displacement of the wave from equilibrium position. This means that kama utakuwepo na wave yako, kama tukiangalia general wave diagram, hii ndio general wave diagram. Hii hapa ni displacement na hii hapa ni time taken. Hii tunatake assumption this one is a string. So nikiplug hapa katikati, nikichezesha ita move in this way. So before ilikuwa hapa, that's why tukaita equilibrium position. But nikidisplace it too from equilibrium position to center point, this one we call it as a amplitude or maximum displacement. Here is amplitude. Here is amplitude. Kwa sababu gani amplitude? Kwa sababu nimeidisturb wave yangu from equilibrium position to maximum displacement. Baada hapo, is supposed to know, and the SI unit of amplitude is meter, kwa sababu amplitude is like a distance. So it's SI unit is what? Meter. And the wavelength. Wavelength, this is the disturbance, is the distance between the two successive points of phase crest or trough. Distance yangu hii hapa tunaitaga ni crest. Hii ni crest. Wakati hizi hapa za chini, ikiwa chini tunataga ni trough. Kwa hiyo ya chini ni trough. So distance from here to here we call it as wavelength. Also the distance from here to here we call it as a wavelength. Or wavelength sometimes is the distance taken by a wave to complete one circle. So from here to here also is a wave length. Sababu hii imecomplete one nini circle. And as a unit of wavelength also is a meter. And we shift to the third term, which is the frequency. What is the frequency, mwanafunzi wangu? This is the number of oscillation or complete circle made by 1 second. Number of circle, this one made per second. This one, 1, 2, 3. Number of this one made per second. We call it as the frequency. And the symbol for frequency is smallest letter F. The unit of second is the frequency. You want to have a frequency, we take number of circle per unit time. So we have per second. The extent of frequency is per second. And the per second, we call it as the hertz. So the extent of frequency is hertz, which means H is Z. Other unit kuna kilohertz, kuna megahertz. Their relationship, note ya kwamba panatuambia 1 circle per second is equal to 1 hertz, and 1 kilohertz is equal to 1 times mega lies per positive 3, and 1 megahertz equal to 10 lies per positive 6. Other terminology which used to describe the wave is periodic time. What is it? Periodic. Periodic, it means repeated. So the time taken by wave to make one complete cycle oscillation, we call it as periodic time. For instance, our wave is complete one cycle from here to here. So the time taken from here to here, we call it as periodic time. And the extent of periodic time is second, simply because it's a time, no matter how. And other unit is millisecond. Next one is microsecond. But in most equations, we use hertz or per second as a unit of frequency. Hata kitokea katika mtihani wako kiuliza what the unit of frequency you're supposed to write is hertz. The relationship between frequency and the periodic time. We say that the relationship is that time is a reciprocal of periodic time is a reciprocal of frequency, or frequency is a reciprocal of periodic time, whereby each symbol carries the usual meaning. It means F, the smallest letter F standing for frequency, and the capital letter T standing for periodic time. The other terminology which used to describe wave is velocity of a wave. What is velocity? This is the rate of change of displacement of a wave. Mathematically, velocity of a wave, V stands for velocity, distance traveled is xt, and t is time taken. So we need to equate this equation with terminology used in a wave, such as the wavelength and the periodic time. So as we consider our general wave diagram here, this one is displacement and this one is time taken. So our wave is disturbed from equilibrium position here, and it completes the circle here. 1, 2, 3, 4. So from here to here is distance covered by our wave, which we call it as wavelength, and the time taken to complete this cycle we call it as periodic time, which is t. So now instead of writing t here, we write periodic time, which is capital letter T, and instead of writing distance x here, we write wavelength, which is lambda. This symbol we call it as lambda. Lambda. So as we substitute our equation there, as we substitute the variable to our equation 1 above there, we have v, velocity, equal to distance x over time, but this one x equal to lambda, and the time taken equal to periodic time. So we substitute this variable into this equation. We have velocity equal to lambda over periodic time is what? T. But when we write here, you get lambda times 1 over t. But this one is a frequency because it's the reciprocal of periodic time. But 1 over t is equal to frequency. Hence, when we substitute there, we have velocity of a wave is equal to wavelength times the frequency. And this one we call the general wave equation, whereby V is equal to velocity of a wave, and the lambda is equal to wavelength of a wave, and the F there is frequency of a wave. So mwanafunzi wangu, ningependa ufahamu kuwa hii equation namba 2 hapa ndio general wave equation ambayo tutaitumia kusolve equation mbalimbali zinazohusiana na nani? Na wave. Kwa leo au kwa kipindi hiki ningependa tuishie hapa. Tukutane tena katika kipindi chingine katika topic yetu nzima ya wave motion, ambao tutaendelea kuangalia wave velocity of a sound wave na some calculation ambazo zinakuwa involved katika wave, ili uweze kufanya mtihani wako vizuri na ufaulu. Ulikuwa nami katika presentation yako facilitator GOBO. Karibuni na tukutane tena katika kipindi kingine. Kama itatokea kama nilivyosema awali utakuwa haujaelewa, naomba uniambie sehemu gani hujaelewa katika WhatsApp namba yangu 0657975566 ili nikuelekeze wapi hujaelewa. Na kama vile vile utakuwa unahitaji msaada wa swali lako lolote katika either topic za form 1, form 2, form 3, form 4, utanirushia kupitia WhatsApp namba hii hapa, nami nitapata kukusaidia. Asante, tukutane tena katika kipindi kingine.